Hello everyone, let's try to solve a logical reasoning set in this video. The question is Arjun, a chess enthusiast, thought of devising a new game called Chess 196 by tweaking the rules of the game. He uses the conventional chessboard which contains 8 rows and 8 columns with 64 cells in total. The columns are named from A to H from left to right and the rows are numbered 1 to 8 from the bottom to top. A cell is denoted by its column name followed by row number. For example, the bottom left cell is denoted by A1. The cells are also called as squares. The squares are of two colors, white and black, and no two adjacent squares are of the same color. Square G7 is white in color. So we have a new game over here which is Chess 196. We'll be using the same chessboard 8x8. We'll be having squares of two colors, white and black. We have been given the color of one of these squares which is G7, and we have been given the color of one of these squares G7 and it is white. Apart from that, we have been told that no two adjacent squares will be of the same color. So by knowing the color of just one of these squares, we can find out the color of all these squares in the chessboard. And the naming of particular cell will be done by taking its column name first followed by its row number. Now after that, Arjun chooses to use only three types of pieces: queen, rook and bishop. A queen can move from its cell where it is placed originally to any other cell in its diagonal only. So a queen can only move in the diagonal positions. For example, a queen placed in A1 can move to B2 or H8 but not A7 or F1. So basically this is regarding the cells where the queen can reach diagonally. After that, a rook can move from its cell to any other cell in the same row, column or diagonal. Then after that, a bishop can move from its cell to any other cell in its row or column only. So basically these are regarding the movements of all these three pieces. For a given position of a piece, all the cells to which the piece can move to are said to be attacked by the piece. So basically if I put a particular piece on a particular position, so all the cells to which it can reach, they will be the cells the piece can attack. So to all the cells where a particular piece can reach, they are said to be attacked by the piece. Any piece placed in one of the cells that is attacked by another piece is said to be attacked. So if one piece is being attacked by another piece, then it is said to be attacked. The cells and pieces that are not under attack are termed as free from attack. So those cells and pieces where no piece can reach, they will be called free from attack. Let us see the questions that we have. Arjun places a queen and a rook on the board, the maximum number of squares that can be free from attack. So basically we have to adjust the position of a queen and a rook on the board and we have to maximize the number of squares that will be free from attack. Second one is a rook is placed on square F2 and a bishop is placed on square E4. The number of white squares in which a piece can be placed such that it is not attacked by the rook and the bishop is. So we simply have to place the pieces on the given position. We'll see all the cells to which they can attack and we'll count those white squares that cannot be attacked by these pieces. Similarly, we have the third one. So let us go to the next slide. We'll draw a chessboard over there. We have to make sure that square G7 is white in color, and after that we'll accordingly determine the color of all the other cells and we'll start solving the first question. So we were told that G7 must be white and this is how we were numbering all the cells. The columns were named from A to H from left to right it was given, and the rows are numbered from 1 to 8 from bottom to top. So yes, that is what we have followed. G7 must be white in color, so yes, G7 is white in color over here. So the first question that we have is Arjun places a queen and a rook on the board. The maximum number of squares that can be free from attack is. So we have to maximize the number of cells that will be free from attack. So what we have to do is we have to adjust the position of queen and rook on the board so that they are attacking minimum number of pieces. Now how to minimize the number of cells that these queen and rook are attacking? First of all, let us find out the manner in which queen and rook were attacking. So queen can attack anywhere in the diagonals. The rook can attack anywhere in the rows, column or diagonal, but they must be the same row, column or diagonal. A rook can attack any other cell in the same row, same column or same diagonal, and a bishop can move from its cell to any other cell in its row or column only. So queen can move only to the diagonals, a rook can attack column, row and diagonal, but it must be the same column or diagonal. Then the bishop is attacking only the column and row, or any cell in its column and row. Now we just have to consider one rook and queen. So we can only minimize the number of cells attacked by a queen and rook when we'll have to maximize the common cells that are being attacked by these both. So basically, if we have a rook can attack in this direction, this direction, this direction, this direction, even to the diagonals, while a queen can attack only in the diagonals. So we have to maximize the common cells that are being attacked by a queen and a rook. So when will this happen? This will happen when we'll put a rook and a queen diagonally opposite to each other and as far as from each other, because then only we'll have maximum distance between a rook and a queen, and the number of cells that will be attacked by a queen and rook, they will be maximum. So let me put the rook over here and the queen over here. These are the positions which are at maximum distance on the diagonal. So now the number of cells that can be attacked by this rook and queen in common, it will be maximum. So this will be attacked, this whole diagonal will be attacked by rook, then the same diagonal it will be attacked by the queen as well. Now this rook can attack this whole row, this whole column. There are no more cells that can be attacked by this queen and this rook. So how many cells are being attacked? See, this whole diagonal will be attacked, this will be attacked, this will be attacked, this will be attacked, this will be under attack. All these cells on the diagonal, they will be under attack. Also this column, this whole column will be under attack, and this whole row will be under attack. Now we know that in total we have 64 pieces on the whole chessboard. So we'll deduct the number of cells that are under attack. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We have 22 cells that are under attack. Wherever I have put a check mark, all those cells are under attack. So 64 minus 22, which gives me 42. Maximum 42 cells will be free from attack. So 42 will be the correct answer to this question. Let's solve the next one. The next question is, a rook is placed on square f2. So f2 will have a rook over here, and a bishop is placed on square e4. So on e4 we'll have a bishop. The number of white squares in which a piece can be placed such that it is not attacked by the rook and the bishop. Now bishop can only attack along the row or column. So these will be the cells that can be attacked by the bishop, while this rook, it can attack this whole diagonal on the all the cells on the diagonal, this cell as well, these cells, and this cell as well. Rook can also attack along the row and column, so these will be attacked. This whole column will be attacked by the rook. So that's it. We have marked all the cells that can be attacked by this bishop and this rook. So what we'll do is, we know there are total 32 white squares, and let us count the number of white squares that are under attack due to this bishop and rook. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have total 19 white squares that are under attack. So to find out the number of white squares that are not attacked by the rook and bishop, we'll deduct 19 from 32, we'll be getting 13. So 13 will be the correct answer to this question. Let's solve the last question now. The question is, a bishop and a queen are to be placed on an empty board such that two pieces do not attack each other and at least 4 squares are attacked by both of them. The queen is placed in the square d3. The number of black squares in which the bishop can be placed is. So we have to place a bishop and a queen. We have to place the queen on square d3. So d3 will have a queen over here. And we have to make sure that the two pieces, that means the bishop and the queen, do not attack each other. Apart from that, we have one more condition. at least 4 squares are attacked by both of them. So we have to take care of two conditions. They should not attack each other, and at least 4 squares must be attacked by both of them. So how many black squares are there in which we can place the bishop? See, we know that the queen can attack fully throughout this diagonal as well as fully throughout this diagonal as well. So we won't be counting all these black squares that are under attack by the queen. Now let us try to find out the black squares for bishop so that queen and bishop do not attack each other. We know that bishop can attack throughout the column, throughout the rows. So it is very clear that we cannot place the bishop over here because then it will attack the queen. Here also it will attack the queen. Here also it will attack the queen. Then here also it will attack the queen. Here also it will attack the queen. Here also. Here also. Now we have to make sure that at least 4 squares are attacked by both of them. So if I place the bishop over here, then they will have only one cell in common that will be under attack, which will be this particular cell. So we cannot place the bishop over here. Similarly, if we place the bishop over here, then also the number of cells attacked by both of them, it will not be 4. So we'll remove this also. Similarly, the bishop cannot be placed over here, not over here. If we place the bishop over here, then also in total they'll be able to attack only 1, 2, 3 pieces. So even this will not be the position for bishop. Then if I place the bishop over here, then also the number of cells that are attacked by both queen and bishop, they will be just 3. So this will also be gone. If I place the bishop over here, then we'll have this piece attacked by both of them, this piece attacked by both of them, this piece and this piece. So this is a position for bishop that is possible. Then let us place the bishop over here. In this case also, this piece will be attacked by both of them, this piece also will be attacked by both of them, this piece as well and this piece as well. So from here also both of them are attacking 4 pieces, so this place will also be counted. Similarly, if we place the bishop over here, this will also be not satisfying the condition. Similarly, if I place the bishop over here, from here also they will not be attacking at least 4 pieces in common, so this will be gone. Similarly, if we place bishop over here, then also it will not satisfy the condition. From this place also it will not satisfy the condition. From this place only 3 pieces will be attacked by both of them, so this place will be gone. From here only 3 pieces, this will be gone. From here just 2 pieces, 3 pieces, so this will be gone. So we have just 2 positions for bishop, so that they are not attacking, the queen and bishop are not attacking each other, and they are attacking at least 4 pieces in common. So the correct answer to this question would be 2. The statement that was given to us in the question, at least 4 squares are attacked by both of them, that means a particular piece has to be attacked by both by the queen and the bishop in common. So that is how we solve this question. So I hope the explanation was clear to you. It was an easy question. If there's a doubt, please ask again. Thank you.